Okay, matrices. So just a bit of grammar first. One matrix, but two or more matrices. It's just one of those Greek things. And they're normally named with a capital letter, so we called it capital A, this one. And we say their size is their order. And you have to know that you're doing rows by columns. So if people remember the word race car, because it also starts with an R and a C. So rows go across, so these are the rows, and then do a different color, the columns are the ones going down. So you can see if we count these, let's do some highlighting. So that's one row, two rows. So let's say 2 by, and then if we go back here, and we can say there's 1, 2 columns, so it is a 2 by 2. And you read that, when you say it, you'll say 2 by 2. And it's important not to get confused that this is a time symbol. It's not a multiplication symbol. It just really, really looks like it. Okay, so all these little numbers in our matrix, they are called elements. And normally, because we've got a big A here, we'd actually name all our elements with a little a. So little a, little a. There's 4 of them because we've got a 2 by 2. That is the order of that matrix, 2 rows, 2 columns. So if we look at the number 1, it is in the first row. Okay, so being in the first row, we would give it a little 1 because we do the rows first. Remember, RC, race car, or Roman Catholic was what I got taught when I was a kid. And it's in the first column, so we give it another little 1 there. Now, if we were to look at the 0, it's in the first row, second column. So we'd say first row, second column. And if we look at the 3, it's in the second row, first column. So in that case, we'd say 2, 1. And if we look at the last number, the 4, it's in the second row, second column. So it is 2, 2. This does seem a bit sort of pedantic and silly, but they do actually do these kind of things on exam questions. Okay, so matrices are just groups of numbers inside square brackets. You must have the square brackets. So these square brackets are very, very important. There have been occasions where people haven't used those square brackets and not got the mark, even if you got the numbers right, so you didn't put the square brackets. So those square brackets are important, must be there, and they must be square. Okay. Another few things, I've got a whole bunch of matrices here to name and talk about. Now, this part of a matrix is called a leading diagonal, because there's another diagonal, but we don't care about that one. So we only care about the leading diagonal normally. The other diagonal goes that way, but who cares? The leading diagonal. We've had square matrices. This one is a row. Number C is a row matrix. And you can also see it's actually it's the second row from B. So it can be a sub matrix. And D, it's only got numbers in the column, so it's a column matrix. All right. We've got a special dude here, which is always called I. This is the identity matrix. I'm going to do a bit more about that in a minute. So that's the identity matrix. Very important. Very, very important. Here we've got a symmetrical matrix, symmetrical. Now you might be thinking, hang on a minute, that doesn't look very symmetrical, but it's actually symmetrical along the leading diagonal. So to highlight that with the highlighter, if you notice, if I go along this first row, it goes 3, 0, 4. And if I then go down the first column, it goes 3, 0, 4. It's exactly the same. And just choosing another color, if we go the second row, 0, 2, 1, and then we go down the second column, 0, 2, 1. That's where the symmetry is. And if we go another color, we can say the third row, 4, 1, 4, 1, neg 1, and then if we go down the column, 4, 1, neg 1. So in a symmetrical matrix, row 1 equals column 1, row 2 equals column 2, etc., etc. And that's where the symmetry is along the diagonal. So you can have different numbers on the diagonal. That doesn't matter because the 3 and the 2 and the negative 1 are actually symmetrical with themselves. Okay. Let's have a look at some more interesting ones. This one, because that makes a triangle, and it's in the upper thing, it's called an upper triangle matrix. And there are no special prizes for guessing the next one is, well, you've got the lower triangle, so it's a lower triangle matrix. And that's just some more naming things. More about the identity. Okay, in normal maths, you used to the idea that 5 times 1 equals 5. And you know that the 1 isn't doing anything. This is actually could be termed the identity. In fact, the idea that a number times 1 equals itself is the fundamental identity of mathematics. You can use that at parties. Now, I does exactly the same thing. So if you said matrix A times I, it would equal A. So the identity matrix is just like the number 1, yes? But for matrices. But yeah, okay. And that's sounds like a really trivial thing. I mean, like, hey, when do you need to use 5 times 1, let alone A times I? But it will come useful later. Now, some things to note about this. I can come in different sizes, but it must be square. So must be square. If I can spell square, square. Okay, that's an important thing. You got 1s on the leading diagonal. Remember that's the leading diagonal there. So on the leading diagonal. And everything else 0. So you can have different sizes. You could have I could just equal 1, like that. Make that look like a 1. Or I could be a 2 by 2. All right, and it could be a 3 by 3 or 4 by 4, as long as it's square. There's 1s on the leading diagonal, and everything else is 0. You've got yourself the identity matrix. You'll use it a lot more, and we haven't even talked about multiplication yet, but it'll all make sense as you go through things. Okay, so you can actually transpose matrices, and so you might say, well, what's B transpose? So what you're basically doing is making the rows columns. So rows become columns, or vice versa, whatever you like to end up being the same thing. So this is a 3 by 3. So we know our answer is going to also be a 3 by 3. But if we go along here, it's 3, 0, 4. But that's a row, now becomes a column. 3, 0, 4. And then we look at the next row, and it's 5, 2, 1. So we go 5, 2, 1. Sorry, minus 5, 2, 1. And then we'll look at the third row, and that's 3, 1, neg 1. And it's quite easy to do these things on your calculator. It's quite easy to do manually. But it's one of the things you need to know about matrices. Now, this also can be done for rectangular matrices. So let's transpose a rectangular matrix. Now, this is a 2 by 3. Remember, that's rows by columns, race car. And so our answer is actually going to be flipping, because remember the rows become columns, so it's actually going to be a 3 by 2, so 3 rows by 2 columns. So let's grab our highlighter pen. So this row, which is the first row, is going to become the first column. 1, 2, 4. And our second row is going to become our second column. And there we go, minus 3, 0, 6. And that's the transpose, so H transpose. So they do flip, and sometimes good to see a rectangular one because square ones sort of hide what's going on there a bit.